Awesome. With all that information in hand, thank you guys so much for taking time out of your day to be with us here at the Veritas AI team. My name is Tyler. I'll introduce myself a bit more in depth with respect to Veritas, with respect to my AI background in a couple slides. But for now, I want to start off by introducing the star of the show, our program itself. Veritas AI is an AI and machine learning or artificial intelligence and machine learning program for ambitious middle school and high school students. It was originally designed and run by Harvard graduate students and alumni who, in their experience at Harvard, realized that younger students very often will and can access AI toolkits. They wanted to make sure those students were set up to do so successfully, ethically. And so this program is built for students to engage in project-based learning in the artificial intelligence and data science space. With that in mind, a little bit about me. So my name is Tyler. I am the head of publication and partnerships at Veritas AI. Otherwise, I'm known as the director of our academic team or director of academics. I myself am a former AI astronomy researcher. I did my research first at the University of Cambridge, where I was doing a research fellowship during my undergraduate. And thanks to a really wonderful mentor I had at the time, I was encouraged to take my astronomy research and integrate AI methods, software, algorithms. That experience let me go on to do a senior thesis at Harvard, which got high honors, led me to, as just an undergraduate graduate, so to speak, publish in leading academic journals, go on to academic conferences, contribute to professional research grants. And so I can speak very meaningfully for the way in which AI and AI mentorship can equip a young student or professional to reach ahead in their career goals. And because of the wonderful mentor I had, I'm a big proponent of the work that we do here at Veritas. I am, for this last bullet point or this last note, a longstanding education nerd. I love the work that Veritas AI does to provide project-based learning opportunities for students so they can apply and learn about AI in the context of driving meaningful work in AI itself or in applied fields like astronomy for me, medicine, finance, journalism, etc. for others. Awesome. So with that in mind, I'm really excited to chat with you guys today about all that is Veritas, which in a gist is artificial intelligence projects for high school students. I'm going to start off with a quick welcome. The first 5 to 10 minutes of today's call will just be meant to orient anyone in the call, especially any students, any parents who are thinking about this program for their respective students, what we focus on or what we think about when we talk about AI. So this is meant to be an introduction to the world of AI or a welcome to the world of AI to kick us off. As I move past this first part of the presentation, I'll talk more about program logistics, different program offerings, more of the nitty gritty as you'd expect for what we do at Veritas. To start off, though, with our welcome, a question I always like to rhetorically ask is, what is AI? If anyone wants to put an answer in the chat, by all means do so. But I ask this question rhetorically to provide a few fun examples. For instance, AI can look like the algorithm driving the search mechanism behind your favorite shopping website. Google, for instance, not just in its new AI features, but in its original construction, had in its search algorithm a ranker brain machine learning algorithm. AI can also look like cybersecurity technology. It's the reason I'm able to get up in the morning, not look my best quite yet, but my phone still recognizes my face. It can also look like autonomous cars or autonomous self-driving vehicles. There are lots of different AVs that exist and are able to operate different areas in the US. This used to be an SF classic. Now it has grown and is well-known information. It's really interesting. I don't know that all three of these examples I just took the time to show you guys all hint at this, but it is true that AI is a technology that is all about finding patterns and complex data that we often can't find on our own. I like to back this up and say for any students, parents, or anyone interested in the crowd today, AI is really just about replicating human decision making, reasoning, thinking essentially in machines. But the really cool things about machines, about computers, is that they can process thousands, millions of data points at rates that humans can't. And so AI is not just about replicating human decision making, but trying to think about how it can be done at really large scales. And so, how can we replicate human intelligence artificially in these machines? And just to provide one quick set of examples that illustrate this, one thing I like to also say or illustrate for students is that AI is often conflated with these other terms, machine learning and data science, but I think it's important to note it's not just conflated. AI overlaps machine learning and deep learning kind of as concentric circles or like concentric Venn diagrams. All machine learning is artificial intelligence, all deep learning is machine learning, but vice versa is not true. Basically, what this is that AI is the broad set of hardware, software, and even kind of ideas, philosophy that encompass the construction of intelligence artificially. Relatedly, machine learning is just the algorithms and software for the most part that compose AI technology, and deep learning is a specific subset of that technology and software that is based off of neuroscientific principles. You might have heard for deep learning the concept of a neural net, which is one of the foundational concepts in deep learning. From there, data science is just this overlapping field. I think this Venn diagram is cool information for a lot of students, but I'd like to break this down with a more constructive example. You might think about AI in the context of a medical MRI machine that incorporates AI. For AI, it might be the entire system itself, including the machine. The machine learning aspect of that machine might just be the algorithms that have been built into and enable the machine to identify and categorize diseases from MRI scans. And then data science might be a process that scientists are applying kind of in tandem with the AI, in tandem with the overall machine, so that physicians can recognize the medical conditions and make sense of an MRI scan. You see how for this application context, the diagnosis is itself dependent on all these things coming together. But each of these things, AI, machine learning, data science, are different parts of that overall process. Awesome. So this starts to get into some interesting points or more blunt points for why students might want to get involved in AI or learn about AI in high school through a program like we have at Veritas. To answer the question, why learn AI in high school, I think it's four big points that come to mind for me. It is learning something new in your area of interest. That is both true for students interested in computer science, as well as students who just want to learn about applying AI in their field of study. For instance, AI is a novel area of application in medicine, in finance. It is something that it can be novel and meaningful in any area. That relates to the last point on the right, creating an impactful project. You can use AI to drive meaningful projects, even as a high schooler, even as a younger professional, student, researcher, etc., to drive impact in your area of interest. And at the end of the day, I will also say AI is really meant to be, or is at its core, a problem-solving toolkit, or at least a toolkit. And so these two central pieces are also really critical. Student is going to learn a problem-solving toolkit with us. They'll be able to add to their creative palette or their creative toolkit in building AI skills. And they'll also demonstrate their technical abilities with us because they're going to learn to apply AI software or code to driving the projects they do with us. And speaking of projects, I think this is the perfect time to chat about a bit more tangibly about what AI projects our high school and middle school students have worked on as part of the Veritas program. This is my absolute favorite part of today's presentation because it really gets into the weeds of what kind of projects you might yourself as a student, or you, a parent, counselor, educator, etc., might see your student working on as part of a program like ours, or just when using AI in this broader world. Awesome. So one of my favorite examples is an AI and visual art project. This is actually our first year of existence for Veritas AI. We got to work with this wonderful student. She was really interested in the way that there are a lot of text to image AI generators that exist in this day and age. Like we now have DALL-E, Midjourney, these different softwares you guys might have heard of that allow a person to input some piece of text and output an image. However, Mridu wanted to understand and study, like, how can you do that in a much more controlled environment? How can you do that image to image? How can I give a computer vision or AI for images classifier a specific image and then blend it to one other specific image? So Mridu explored this application and built an app, and out of that app also wrote a research paper exploring how you can take an image like this one, feed a classifier or teach a classifier the elements of an image like Starry Night, and blend those two together to make a final output. Awesome. So we also have students like Pratham who've used AI for sign languages or just AI for language barrier breakdowns. Pratham specifically wanted to use AI vision technology, similar to Mridu, but very different context, to explore how AI can be used to break down and automatically recognize, translate sign language. So it's how you can apply AI for video and image technology to break down language barriers in this kind of context. Awesome. Another really cool thing, a trend I've seen across student projects at Veritas is an interest in renewable energy and climate change. One student, Faria, explored how if you have weather data on a city, climate data, if you have data on how different kinds of renewable energy sources like solar, wind can produce different amounts of energy, and you have a certain budget a city has, how can a city optimize the renewable energy grid to drive the best yearly renewable energy replacements for electric? And so she looked at how you can combine all these different data points to teach a city how to best invest its money across different sources. A very, very cool project that shows how AI can be driven to drive from millions, thousands of data points, meaningful insights for a city looking to invest well in renewable energy. Awesome. And one last example I like to quote is just AI sports. The reason I think this is a fun example is that I was a student athlete and myself in high school played soccer, just like this example. But I always thought of being a student athlete and being a student kind of separately. We've had a lot of students who've bridged that gap in their projects at Veritas. So Krish, for example, explored how you can use neural networks to predict from historical game data and season data whether or not a specific set of teams will have certain outcomes in forthcoming matches. He used it specifically to make predictions for La Liga matches between Barcelona and Real Madrid, which is a really cool application in sports data analytics, sports business development. Awesome. And that is just to say, all of these examples illustrate quite well the fact that AI can be used as an application or as a tool in just about any field of study. We have seen students use AI for cryptocurrency forecasting or other business development contexts. We've seen students use AI for cancer detection, AI for developing a responsive video game. You can use AI as part of our internship program I'll get more into later to build an AI-driven landing page or a chat bot for consumers. AI is really meant to be a toolkit at the end of the day. That's not to say it should be used in every field of study, but it can be used in every field of study to drive meaningful, impactful, novel results or projects. And that is a really great segue to talk a little bit about how beyond careers in AI that we all know students are becoming increasingly accessible, the specific kind of programs we offer to students to be able to work on these kinds of projects. So with that all in mind, this next part of today's presentation will be just another 10 minutes max. It is meant to give you guys more of a logistical introduction to what programs are offered at Veritas AI. If anyone has any questions along the way, again, please drop them in chat. Otherwise, I'll take time at the end of today's webinar or today's info session, whatever you want to call it, to chat with people directly in a Q&A. Awesome. Yeah, let's get into it. So talking about our programs, the first thing I want to say is that we have both middle school and high school programs here at Veritas AI. I'm going to go through our programs in the next 4 slides. The first slide is just going to be for our middle school programs. We only have 2 main programs for middle schoolers. For high schoolers, we have 3 whole categories of programs, which will be the rest of what I cover. For middle school, though, we have 2 main programs. We have the AI Trailblazers program, which is our introductory boot camp or group class for middle schoolers. And we have our junior fellowship or our one-on-one research program for our middle school students. For high schoolers, we have boot camps and we have research programs. So we'll talk more about that as relevant to high school students soon. Please note that I'm also going to talk about internships for our for our high school programs. We unfortunately do not have internships for middle school students. If you are interested as a middle schooler internships, wait a couple of years, we'll have that option available for you for sure. In the meantime, though, you can enroll in either of these programs, our AI Trailblazers program or our junior fellowship. As I mentioned, our AI Trailblazers program is a boot camp. It is a camp that takes place 25 hours over 10 sessions or 10 2.5-hour sessions, where students will work on the fundamentals of coding, machine learning, and go on to work on a group project with 3 to 4 other students. The junior fellowship, by contrast, is a session where you'll have 12 one-on-one meetings with a mentor or an AI expert, and you will go on to complete a novel AI model in your field of interest, as well as a research or project report on your findings. You'll also get a personalized mentor evaluation from your mentor, of course, which can be a great aid for middle schoolers thinking about any boarding school or private school applications they might submit as they look towards high school and the next stage of their academic and professional career. Awesome. So that's our middle school programs. The next 3 slides I mentioned will go in depth on our high school programs. And specifically, I'm going to cover first our boot camps, second, our high school research programs, and third, our AI internship program. First, our boot camps. So our boot camps follow a similar structure to our middle school boot camps, but they all have an accelerated curriculum relative to our middle school boot camps. In particular, our high school boot camps will all touch upon not just coding, data science, machine learning, but also deep learning. And they'll also get deeper into the math and statistics driving AI, as well as the project topics being a lot more mature and developed for our high school students. In terms of our offerings, we have three main kinds of programs, or sorry, three main kinds of boot camps. Our AI Scholars are interdisciplinary introduction to AI, or our AI Finance or AI Medicine deep dives, where students will learn about all things AI, but specifically applied in that field of study, either finance or medicine. Awesome. So we let students know that our boot camps are meant to be introductory spaces. Again, our boot camps are leveled though. So if students come in with a high code background, we'll put them in a high code class to make sure it's appropriate for their level of coding background or computer science background. But our intro classes or our boot camps are where students can enroll if they have no coding background. From there though, our research programs for high schoolers and our internship program for high schoolers is specifically intended for students who either have done a previous program with us, like our boot camp, or who already have coding experience from school, from a previous personal project, something like that. With that in mind, our two advanced programs for high schoolers are our research programs on this slide and our internship programs on the next slide. For our research programs, we have two main programs we offer high schoolers: the AI Fellowship with Publication and Showcase, and the AI Accelerator. In both programs, you'll work one-on-one with an AI expert, as well as one-on-one with, in the fellowship, a publication expert, and in the accelerator, a publication and competition expert. The main difference between these two programs is threefold. It is one, the number of sessions with your mentors. It is double for each session. It's 15 to 30 for the fellowship to the accelerator. Given the double number of sessions and length of the programs, the second thing that's different is that the complexity of the project should always be deeper. For example, the AI fellowship will often result in machine learning or a simple AI-based project. The AI Accelerator likely will involve a deep learning and more complex AI project. And thirdly, the final difference between these programs is that at the end of the AI Fellowship and Publication and Showcase, typically at the 12th session, the students will have one output we're supporting them on. That's usually going to be a submission to a high school level journal. In the Accelerator, we're going to support them on at least two outputs at meeting 24, or when they finish the project and go on to Showcase. Those two outputs are a high school or college level journal publication and a competition or presentation submission. So we support them with double the number of sessions, double the amount of support, and double the complexity of projects in the accelerator. If students, for instance, really want to go to ISEF or try to compete towards ISEF, for example, is a big question we get, we recommend the accelerator. Awesome. So the last program we cover is our high school internship program. It's the AI internship. It is an 8-week or 2-month program where students will have 8 sessions one-on-one with the company manager and 4+ sessions with company leadership. The program, again, requires basic understanding of Python or having completed a program with us before, and will result in professional level project presentation, as well as a technical output they've built for and as part of their internship with the company. They'll also have a signed letter of internship completion directly from the company, and not guaranteed for any of our advanced programs, but often something our students can also get is a letter of recommendation from either their research mentor or their company mentor, as long as they had a good relationship with that instructor or that guide, manager, etc. Awesome. So that's a quick overview of all of our programs. And the one last thing I want to say before I go into the last part of today's presentation, just logistics for applying, is just a huge shout out and nod to our amazing mentor team. We have, this slide is not comprehensive. We have somewhere around like 130 to 150 mentors who run the full gamut of AI applications and interest areas. We have awesome mentors like Gina and Kirti to use AI in the bioscience and the medical space. Mentors like Yishao, who are pure statistics and AI professionals. Emily, who is now doing space robotics for NASA, or will be as soon as she finishes her PhD at UMich soon. We have mentors who run the full, as I already mentioned, gamut of AI interests, who are so excited to work with and engage students as part of this program. Awesome. So with that in mind, I have a couple questions from the chat that I want to answer just very quickly because they are relevant to today's, or this part of the presentation. Specifically, someone said, could a middle school student do the high school level fellowship if they have a good Python programming background and if they can prepare for a showcase at a local science fair? So for the middle school program, we do not offer the high school program for middle schoolers explicitly because middle school students are not eligible for most high school publications. If a student does our middle school junior fellowship, we will support them on a middle school science fair, although there are very limited opportunities there for students. It's an important warning. That's again why we do not let students in the middle school level into the high school fellowship. One other question I got that is incredibly relevant for these slides is very specifically, do we support projects that integrate hardware such as Arduino. So we have supported students on remotely navigating, working on Arduino or other kind of Raspberry simple engineering-based projects. But please note, since our program is remote, that kind of instruction will be provided from the mentor to the student remotely. If there are any safety considerations the student needs to consider, they will need to have access to a lab through either a university or their high school or another facility. We can't provide lab space or lab materials. They would need to be mentored and monitored remotely. Awesome. There's a couple other questions in chat. I'll answer them as we transition to the Q&A soon. But now, just to go through the last part of today's presentation, a quick overview of our admissions criteria and course details. Besides the coding background required for our advanced programs, the three main things we're looking for in a student application are academic drive, commitment, and curiosity. This is especially important for our advanced programs, thinking about who our top mentors will work with. Our companies both evaluate your application and will evaluate your interview results. Our internship program specifically has an interview I'll cover in the next slide. So we encourage you to put your best foot forward, making sure you're covering your coursework, your extracurriculars, how they integrate into your interests in and outside of our program. Make sure you're identifying in your application that you're committed to and ready for the program for the program duration and inputs. And make sure you show us you're curious. We want to see, as part of at least one or two questions we ask on the application, what you are interested in and what makes you excited, curious, intrigued by the world of AI. Awesome. To give a bit more logistics in the application process, so the first thing students will do is submit an application. There's around 3 or 4 short essay questions we ask students to submit, no more than 200 to 250 words. Please just do your best to put your best foot forward on this. Typically, it takes students no more than 30 to 45 minutes to complete the app. Typically, it takes even less if you're already applying to other summer programs or other programs with parallel applications. From there, if you once you submit the app, if you specifically apply to the internship program, there will be an interview stage. But otherwise, post the internship interview or post submitting your application, you'll usually wait to hear back from our team 2 to 3 weeks on step 2, the admission decision. If accepted into the program and you choose to move forward, either paying for the boot camp or submitting a deposit to get your mentor match, and then submitting your full payment to move forward from the admission notification, you'll then be launched into the program either for your group class or internship timing, or at your discretion for the research program, which has a rolling start date. Awesome. And just in terms of the upcoming application deadlines, our summer one deadline will be coming up on March 16th. Please do your best. Oh, sorry, actually, this will be March 23rd. Sorry, this slide is not updated. Our summer one deadline will be March 23rd. Please make sure to aim for this deadline if you're aiming for a research or internship slot. It's especially important for prioritizing you for a top mentor or company match. Outside of that, the summer 2 deadline is going to be April 20th. We will absolutely still have slots across all of our programs by April 20th. But again, if you're aiming for one of our more competitive programs, want a top company or
You're not even listening?
match, by all means, please do your best to apply earlier rather than later. Awesome. So that's the end of the info session today. What I'm going to do is go ahead and stop the recording. Thank you all so much for watching.